Commons, and today we have with us Marc Boorshtein from Tremolo Security, and I've asked him here to talk a bit about Tekton and tell everybody, give a good intro into Tekton CD. And if you don't know Marc, really, you've been missing the boat. Marc's been a long time OpenShift Commons member and been on stage, done lots of briefings on all kinds of topics, and so we're really grateful for him sharing his knowledge around Tekton today, and grateful for him for coming today on such an auspicious day in the American election cycle, shall we say. So we're grateful that he's here and that you're all with us today too. The way that we're going to run this is if you have questions, ask them in the chat wherever you are, in BlueJean, Facebook streaming or Twitch streaming or wherever, and we will bring them to Marc in the chat here and get him to answer them for you. And with that, I'm going to let Marc introduce himself and the topic, and we'll just roll on here, and at the end, when he's done with his demos and everything, we'll have a live Q&A and conversation as well. So take it away, Marc. Again, thank you very much for everything you do.
Oh, thank you, Diane, for giving me a chance to come on and talk. This was a lot of fun. So what we're going to do is we're going to talk about Tekton CD. So real quick, my name is Marc Boorshtein. I'm the CTO of Tremolo Security. We do open source identity management software. If you're looking at specifically in the OpenShift and Kubernetes world, we do OpenID Connect and authentication. We also do automation. I'm also the co-author of a book that'll be released, I think, Friday, November 6th, Kubernetes and Docker, an enterprise guide. And the research I did for that chapter around building a platform used Tekton CD as the pipeline system. And so we're actually going to be walking through some of the results of that research. So I hope we're going to have a lot of fun. So let's start a little bit with giving some context to how Tekton CD is different from Jenkins. In the OpenShift world, Jenkins has been very well integrated since, I think, the beginning, right? Since 3. Red Hat's always had a really great way of making Jenkins a cloud native system. And so if you're used to that, there are differences with the way that the Jenkins system worked and the way Tekton CD works. First off, Tekton CD, every task is a container. Every discrete unit is a container. This brings a lot of power, but it also means that you have a little bit more work to do when you define your pipelines. Because every task is a container, containers are ephemeral. You need to be able to keep that in mind as you build out your pipeline. The big upside to that, though, is that tasks can be built to be reusable. In fact, Tekton has a website dedicated to reusable tasks, and anything you can do in a pod in Kubernetes, you can do in a task. So that makes it extremely flexible. Jenkins, your entire pipeline runs in a container. So that makes for a simpler implementation, but that now means that every container needs to, or the container that runs the pipeline needs to contain everything the pipeline needs. So you end up having a lot of one-off containers to run pipelines. Tekton is an operator that watches all instances of its objects across namespaces, whereas Jenkins, you tended to have your own Jenkins for each application. Multi-tenant Jenkins is pretty hard to do correctly, and as different applications need different plugins, it was just a lot easier to manage your own Jenkins instance. Whereas with Tekton CD, you just have one set of containers that actually does the work of orchestration. Now, of course, you don't have to worry about running the pods. That's what Kubernetes is there for. Your pipeline objects in Tekton are a collection of tasks, whereas if you're using the Jenkins pipeline object from OpenShift, that's basically a single object with a big script in it. So again, more to manage with Tekton, but a lot more flexibility. And then finally, the last one that I'll touch on here is that when your webhook triggers are using Jenkins, Jenkins is a web app, so it's just another URL in the web app. Whereas with Tekton, your triggers actually have to run as their own persistent container waiting for those webhooks. So there's a lot of flexibility in Tekton. that really outweighs the legacy Jenkins implementation, but there's just a lot to manage as well. And we're going to touch on all those pieces. So let's talk about building a pipeline. So we're going to build a really simple pipeline for an application running inside of a GitOps mentality. So the idea is going to be that we're not going to be touching Kubernetes or OpenShift at all directly. We're not going to use the OC command except for maybe viewing some logs. We're not going to be creating manifests manually. We're going to do everything inside of Git. So that leads to some fun challenges that we'll go through. But first, let's start with our pipeline. And your smallest unit of work is going to be a task. Now, a task doesn't have to be a single step. It could be a series of steps, but you want to think of it as this a single unit of work. What is a single task that it's going to do with some discrete inputs and some discrete outputs? So our very simple Python microservice, hello world, which, the service itself doesn't really matter for this conversation. We're going to want to take that Python, generate an image tag for it that's unique. I'm a big fan of putting date and time stamps into my tag, so I have a better way to track it by just a glance without having to go look up some metadata. We're going to build a container, push it into our registry, and then finally, we're going to run a task that will check out a Git repo specifically for our manifests to run our service that Argo CD is watching, patch it with the new tag, and push it back in. That's 3 distinct units of work. So we're going to have 3 distinct tasks. Now, something to keep in mind as you're designing your tasks is that because these are containers, they're ephemeral. They don't have any permanent storage. So if we're going to generate our task or our tag up here in task 1, we need to store that someplace so that it's available in task 3 and task 2. So we do that by creating a workspace inside of our pipeline. And that's what binds these containers together and provides a kind of a scratch pad where we can put files and environment variables, things of that nature that can be securely transferred from each container. Now, as we have those tasks and those tasks have been built, we now have an input and an output. The idea between having these different types of objects is that, again, the tasks can be reusable. So when we take a look at the tasks, and we will look at them real quick, one of the main things to keep in mind is that you want the task to be able to live on its own. So by having additional objects for input and output, you actually make it easier to reuse the tasks. And we bind all these things together with a pipeline. Pipeline references these objects. So if you were to look at it in a graph, you'd have your pipeline with lines out to your inputs and your tasks to kind of pull everything together. Pipeline's also where you define your workspace to be able to transfer information between the different tasks. Now, once you have a pipeline, you want to run your pipeline. So that is a different object inside of Kubernetes because everything is an object, right? All APIs are built around objects in K8s and OpenShift. So to run the pipeline, you would create an object called a pipeline run. But that's not really great. We don't want to do that ourselves manually every time we want to run a build. So that's when you use the triggers project and specifically an event listener. Now, an event listener is a pod that will run basically a web server that's listening for webhook pushes. So whenever your GitLab or GitHub instance is ready to push your code, it's going to call a webhook. That webhook is running inside of this event listener. It's a persistent pod. You need to tell the event listener to generate the pipeline run by using something called a trigger binding. There are a lot of objects here to get this all working consistently. Brings a lot of power, but there is a lot to keep track of. So you create your event listener, that's listening for webhook pushes. That'll create your pipeline run via trigger binding. You are now able to automate the process of kicking off your builds. But you need to be able to reach it, right? Because a web server running inside of your cluster, it needs some kind of ingress or route to be able to expose it. So the next thing you need to do, create a route object that exposes your web application, your event listener for webhooks to be able to push in. So then the next thing we need to do is integrate it with our code infrastructure. So we have ourselves GitLab in this particular demo. And what we want is our developer to be able to push the code. That code gets pushed into GitLab. You know, maybe you're doing a merge, and maybe you're doing a merge, however you're handling it. We're going to be doing a merge in this particular workflow. And you want that to kick off. Well, that means you have to tell GitLab where that route is. Well, now we have to start thinking about security, because I could kick off this pipeline and that could actually cause some unexpected behavior if not done when as expected, right? So we create a secret, and I created these little dots here to kind of show where the secrets line up. So we're going to create a secret for the event listener. There's just big random nonsense data. We're going to put that in the event listener, and we're going to put it in the URL that we configured GitLab for. So that way, you really have to now know this extra step in order to kick this off. It's not ironclad, but it'll stop a random script from kicking things off, even accidentally. So let's talk a little bit about the GitOps model. In the non-GitOps model, when we're done running our pipeline, what we might do is run a patch API request into OpenShift that says, go update this deployment or deployment config with a new image tag. Or we might run an API call against an image stream to have it import. Well, in the GitOps world, you don't want to call those APIs directly. You want to let your GitOps controller do that. In this case, Argo CD, which means we need to patch, we need to check out code, our manifests, patch it locally, commit it, and then push it back into GitLab. Well, we don't want to just let anybody do that. I mean, you could, in theory, go into GitLab and start pointing it to some random container that could cause all sorts of havoc. So we're going to create SSH keys inside of GitLab for our operations manifest repo, so that secret, that repo can only be updated by our GitOps pipeline. So that's another secret that has to be generated and managed. And so then with the output of this pipeline, we're going to have an image, right? We're going to patch our repo, but we're also going to have a new Docker container. Well, that image is going into a registry, and you're probably going to want to have some security on that registry. You don't want to just let anybody push an image into it. Now, this particular pipeline, that's actually exactly what we're doing, because we didn't want to get too deep in the weeds there, but yet another secret that you would want to manage in real life. So you've got a handful of secrets here. You've got a bunch of objects. If you feel a little overwhelmed, so did I. So there's quite a bit going on here. And what you're going to find is that in order to do this consistently, automation is key. Bespoke development of these pipelines might get you through one or two, but you want to do this en masse, then you really need to understand how you automate the process. So I've been talking about GitOps, and we're not going to go too deep into the process of GitOps. The main idea behind GitOps is that you're using a Git repository as your source of truth. So you're not running kube control commands to update objects inside of the API. You are checking code into Git and then relying on the workflows in Git to manage that process. So in order to do that, we've got three repos. We've got an application code repo, and that's our main input for Tekton CD. That's where our microservice is going to go, or our application is going to go. We're going to have build code. So this is the code specifically for Tekton. And these are your Tekton manifests. Now, what's important about this build code is we're going to run it in its own namespace outside of our application. The reason we do that is all those secrets, we don't want everybody to have access to those secrets. We want to make sure that only specific people have access to those secrets. And so we run it in its own namespace. There can be an argument made that it should run in its own cluster, but that's another show. And then finally, we have our operations code. And we actually have two repositories for our operations code base. We have a production repository and a fork of that that's development. So the idea is going to be that I do my work in my personal names workspace. I merge that in to dev for manifests. That then will deploy into a dev environment. We're happy with that. We run a merge from dev into production, and then our GitOps controller picks it up. Now we're going to use Argo CD. We're not going to really talk too much about Argo CD because Argo deserves its own show. So with all that, again, if you're feeling overwhelmed, that's probably a good thing, to be honest. So this is a graphic I had mentioned before that I co-authored a book. This graphic's right out of a book. It's the object map of all the different objects that we created in order to make this all work together between GitLab, Argo CD, and OpenShift. And you can see there's a lot of them. So what's really important, again, I can't stress this enough. You get used to it the first couple of times, and then to do it en masse, you've got to use automation. That's the only way you're going to be able to maintain your sanity through all of this. So with that said, let's go ahead and see how this all comes together. So I'm going to go ahead and show all of my Firefox displays here. Am I missing a Firefox? No, because there's a terminal there. So what we're going to do is we are going to create a new application, what I'm calling a application. That's going to provision all those objects that we saw in that map across Argo, GitLab, and OpenShift and Tekton. Then going to go ahead and deploy that application into the dev environment, watch the build, and then get running in prod. So let's start off by creating a new project. So I'm going to log into OpenUnison. OpenUnison is my company's open source project, and that's going to be really the engine of the automation. And the first thing I'm going to do is I'm going to log in, and I'm going to request that a new application be created. So I'm going to call this Python test 15 and demo. So this opens up a request. This is like trying to avoid the email shuffle of, hey, can you do this for me? Can you create this? Or, even a snow ticket, you might integrate with this for some automation. So I'm going to go ahead and log in as an admin. So I can approve the request. You can see here, I've got this open approval. Let's review it. And let's go ahead and confirm that approval. Now, before I move out of here, let's go over to OpenShift. And we can see that a lot is going on here. We're provisioning things into GitLab. We're provisioning things into OpenShift. So this is actually going to take a minute to create all those objects. So we'll go ahead and give that a second. So while those objects are creating, I'm going to go ahead and kind of show off our tasks here. So our tasks, we talked about them before. Let's get a little bit into the nitty gritty of what they look like. So the first one is actually going to be this generate image task. So tasks, think of tasks as a one-to-one with images or with pods. They're sort of like a deployment in that they're a pod plus other stuff. So our task in this instance is going to generate a tag based on the current timestamp. We're going to save it someplace. So you can see here, I'm not entirely sure why code thinks this is all wrong. So you can see here that we have our input is our Git resource, our output is our result image. And then we just have an image here, this git commit image is just a simple image that I created that had all the tools that I needed in order to be able to do what I wanted. Again, pod, right? You can do anything in Tekton that you can do inside of a pod. What I'm not defining here, though, which you might be used to in like a deployment or a deployment config, is your mount points. That all gets defined inside of the pipeline. And so I just run a script, really nothing crazy here. It's just a bash script that is going to generate an image tag and store it into this directory. So when we look at the pipeline, we'll see that there's a mount point to Tekton results that actually lets us go ahead and save information into that workspace. The next thing we're going to do is we're going to do our build. So we're using a tool here from Google called Kaneko. Podman would work just as well too. And that's going to generate a Docker image without actually having to have a Docker daemon installed. And so we pass the information in. Here's our image URL, and here's our, there's our image URL that has our tag in it. And it's going to go ahead and generate an image based on our Docker file, push it into our registry. And then finally, we're going to patch our deployment. So this is where the GitOps side comes in. So again, just like our first task, what we're doing is we're running a pod. There's a push secret that is being mounted. Okay, so there, the volume mount is there, just not the workspace. And so that push secret is an SSH key that we can use to talk to GitLab, pull source, and update it. And the work itself is actually pretty straightforward. We're getting our Git host. We're copying in our SSH keys. We need to be able to copy our SSH keys to some place that's writable. Otherwise, SSH is going to get really unhappy. We need to make sure that we're able to talk to Git, so we do an SSH key scan. And then finally, we pull out, we run our Git checkout, we patch, commit, and push. At that point, Argo CD is going to pick up the work and move forward. An eye on time here? Yeah, we're good. So let's go ahead and just check. We should be done. Great. So first thing I'm going to do is I'm going to log out here, and I'm going to log back in as our original user. So I'm logged in, and let's go ahead and sign in down here to GitLab. There we go. And let's sign in to Argo. So GitLab and Argo are both integrated via SSO, so we can, we're all logged in at the same time for everything. That's why you didn't see an additional prompt. Now you can see here that I've got multiple Argo projects. I've got a build project, I've got a dev project, that's our dev operations project. I have our production project. Each of these are linked to GitLab repos. So my GitLab build, or my Argo CD build project over here is linked down here to my Python test 15 build project. So that's looking for updates to that code base. The dev project is looking at my dev operations project in GitLab. And then finally, my production is looking at my production application object. So let's start with the application code. So first thing I'm going to do is I'm going to go ahead and I'm going to fork this into my own personal repo. Beautiful. And let's go ahead and run a clone. Oops. All right. Let's clone that. And let's just copy my application code in. So we push it into GitLab, give it a quick refresh here. Okay, great. We have our code, right? Nothing crazy there. So next thing we're going to want to do is let's go ahead and deploy our operations code. So we're going to go over to our test 15 dev operations. So this is our development project for our manifest. So this is where our deployment is going to go, our service is going to go, our ingress is going to go, stuff like that. So let's go ahead and clone that. Now, ideally, we wouldn't be doing this directly into here. We would, fork it into a personal repository and then do a bunch of merges, but that doesn't really demo well. So we're going to clone that. And let's go in there, operations. So code's in there. And before I go ahead and push everything, let's come over here to Argo. And we can see here that it's not really showing much is going on. All right, so that is on its way. And if we give this a real quick refresh, see if it got picked up. It did. So we can see that Argo CD has picked up the manifests that have been pushed into the environment. And we're pointing to this broken image that doesn't exist. So what we're going to see here in a moment is, oh, it's already here. We've got this little broken heart, right? That's because the image is in a crash image pull loop because the image doesn't exist. We haven't created it yet. So once we go ahead and we run this pipeline successfully, the next thing that we'll see is that that will automatically pull in the right image. So let's go ahead and set up our pipeline. So now we're going to go to our build project and let's go ahead and clone that. Now, before I go ahead and push this out, I do need to make one update. Stage Python build. Refresh this. I make a mistake. I think I did.
Mistakes are expected.
Yep, there we go. So we've got, I think we have a few extra things here now. Should have a couple of extra things. Am I not seeing here? Where aren't these tasks copying in? Star, right? Oh, helps if I actually knew how Linux, worked. All right, there we go. Now we got some extra stuff. So go ahead, refresh on there. There we go. Now we have all our extra stuff. So we have our tasks, we have our pipelines. We take a look at our pipeline, and this is what pulls everything together. So we start off defining our parameters, our inputs. We define our tasks, references, task definitions, and so that pulls everything together. So we need to make one update. So in our build template, we are defining where we're actually going to push our Git repo to. So I'm going to go ahead and update this to say, yep, we're going to go to 15. And I'm going to double check this because when I do make mistakes, this is where it happens. So we're going to push this to Python test 15 dev, Python test 15 operations. Beautiful. So what we're going to do is we're now going to go ahead and push this into Git. And if we come back here to our applications, let's look at our build. Come on. Oh, there we go. So if we go over here, we can see that it's synced up and, oh, no, wrong one. Build, here we go. So it's synced up. There we go. So it's synced up. And we've created a bunch of objects, and now our pipeline's actually ready to go. We have our trigger bindings, our templates, our tasks. Everything is set up. It's ready to go. We can now go ahead and move our code into the system, so into the pipeline. So we're going to go ahead and I'm going to fire up our Tekton dashboard. Now, this dashboard is still really early stages. It's not at all ready for prime time, especially given the fact that it does not yet support any like authentication or anything. So obviously you can see here that we have our hello pipeline, and we can take a look at it and create pipeline runs, but we're not going to do that quite yet. So the next step is to go ahead and merge our code from my personal workspace where I've been doing my work for the application into Dev. That will then kick off, or into the main repo. That will then kick off the pipeline. Come in here. I'm going to create a merge request. And we could put some other information in here. I'm not going to go nuts. And this is where I can merge. So you're noticing we haven't actually run the OC command to do anything. And you can see Argo's already picked it up as deploying objects. So we come over here to pipeline run. And we can see the pipeline run's kicked off. And it's creating the image. So it already ran the first step, which was the create image tag. So that step ran. Now it's going to go ahead and start the second one, which is the build process. So that's running. And we can see the logs. Logs are fun. This one actually takes a minute. Diane, do we have any questions in the queue that I can maybe start hitting on?
Let me just see. Manish is just asking for all of your steps. Are your steps and walkthrough available for them to run through themselves somewhere?
Yes. So the GitHub repo itself is published. I need to publish the OpenShift version. And then how to do this like all step by step, that's in the book, and there'll be a link for the book at the end with a 25% discount.
You ask and you shall receive, Manish. Anyone else?
So
I can see some movement on the screen. So
yeah, so what we ran was we built our container. Container went ahead and, building a container, right? We all know how to build containers, pushed it out. And then our last step was updating our Git repo. So that went ahead and patched it. So I come over here to my applications, and here's production. Or I'm sorry, not production, dev. So I come over here to dev, and we can actually see in a moment, and I'll show you here. Let's come to our Git repo and dev operations, and we can see that we have this new commit, and the commit references. So this commit is actually the commit from the application repo. So that's how you can tie a change to your development repo to a change in your application. So you're actually tying it all back. And you can see here the changes were to update that tag. And for some reason, that got flagged as a change. But now that that's in there, see if Argo's picked it up. It has. So we can see that Argo picked it up, updated the deployment inside of Kubernetes. That created a new pod to get rolled out. We now have this nice little green heart in dev. And our broken heart went away. So that fixed our loneliness. And so now we have our application running in development. This would be a great time to run whatever automated test cases, however, whatever your QA process is. Now the next step is we want to go to production. And while this technically doesn't have anything to do with Tekton, I just think it's really cool, so I'm going to show it off anyway. So let's come to our production. We can see that nothing's going on here because nothing is in our production namespace. Excuse me, our production repo. So let's come back here to GitLab, and we're happy with this. And because this is a fork, we're going to go ahead and do a merge. Go ahead, open up a merge request. And we'll see that, we hadn't really put anything in there yet, right? So let's go ahead and submit the merge request and run the merge. So we now have code in our production namespace, and there's Argo CD picking it up, pushing it into prod. So we now have an automated pipeline with Tekton and GitOps, and all those different objects were created automatically. And in this particular instance, we go through this in the book and how we separate the workflow and how we design the workflow. We talk about from a multi-tenant standpoint, making sure that you're breaking it up in all three applications in GitLab, Argo, and in Tekton, Kubernetes. But the other thing that's really great about this approach is the audit trail. We're actually keeping track of, I'm going to go ahead and log in here again and show you the audit trail of all those objects getting created. So you now have the ability to say with confidence, not just when things were created, but why they were created. So if I go to our audit reports, change log for period. Nope. That. So all those objects we talked about getting created, here they all are. If I get to the right workflow, here we go. So here are all the objects that are being created inside of Kubernetes, inside of GitLab, inside of Argo CD that makes all of these things work together. I said we're in an identity management company at the beginning. That's kind of our take on our spin on automation, is making sure that everything comes together. So you can now audit from an application running in prod to where it is in dev, why it was merged, all the way back down to why everything was created in the first place. So yeah, so that's the whole demo. We got some time for questions before we actually, you know what, let me come back here because I made a promise. I want to keep that promise. Did the demo. So connect with us. And here's a link to the book. We'll have a direct link inside of the show notes, I guess. And through November 15th, the code 25 Kubernetes, I think it only works in the US though, unfortunately, for a 25% discount on the book. And the book's got, more than you'll ever want to know about Docker, to be honest. And then things like doing backups of your cluster, authentication, deep dives into RBAC and pod security policies. Falco is covered in there for monitoring your containers, and then the demo you just saw is kind of the culmination of the last chapter where we talk about building pipelines and building a platform. So that's everything. Do we have any more questions, Diane?
Well, I'm not seeing any questions. I think everybody's going to buy the book is what's going to happen. Can you talk a little bit?
So.
Are you're using the open source side of Sysdig Falco a little bit? That's how that helps you in your enterprise here a little bit.
So I'll actually be honest. My co-author wrote the Falco chapter. He works at a big bank. It was interesting, the breakdown of the way we wrote the book. I wrote most of the security chapters. He wrote most of the kind of sysadmin chapters. But Falco was the one area where he just had much better experience than I did. He's manages Kubernetes clusters at one of the top like 5 banks in the world. And so his deep experience was just amazing in the area. So he's been a big proponent of Falco. I know he's had discussions with folks that are like, well, we don't let people exec into pods. Like, well, okay, that's great, but do you want to have that single point of failure in your system, or would you rather have something that'll tell you when somebody's execed into a pod? I'm like, all right, that's actually a good point. So as always with security, it's really important to have that defense in depth where you've got multiple failure points covered, so that if one particular aspect fails, you've got something else to back it up while you're figuring out what the issue is. And Falco is a big part of that.
Yeah, we're gonna have to, like, I keep asking, having trouble with my video here, so I apologize. I love the Sysdig folks, and they've done some amazing stuff. I'm gonna have to get the Falcos in there. Maybe we can get your co-author there to join in a conversation around Falco and using that and demo that in action as well, because there's so many different pieces. It's amazing always to me that how much of all of our world is pretty much open source now, and you have an enterprise guide, but Falco, and Kubernetes, and all of these things. It's pretty amazing to me, this new kind of world that we're living in. So it's just awesome. So we don't have any questions, which I think is amazing, because this is a pretty complicated topic, and I'm really grateful for the tour de force on how to use it and how to deploy all of this stuff. It's pretty amazing. So tell me what's next then for you guys. What's your next book? I know it took a lot of time to write this one, but like, if you could have another 6 months and no work and just content, what is the book that you would write next?
So I actually really want to expand upon the stuff that we covered here. I don't really feel like we did it justice in the last chapter of the book. We don't really touch on things like security scanning. We don't touch on things like automating builds based on different events. So as an example, having something that's looking for CVEs that get patched and then kicking off a build based on that. We don't really cover that. That's this is kind of that starting point, but there's so much more to get into there. We don't really cover a lot of the. We start to touch on the enterprise side of the business management around clusters, but I would really love to do like a deep dive into discussions around multi-tenancy at both the cluster layer and at the namespace or project layer. A lot of people are doing really interesting things right now with like hierarchical namespaces, and using that to help map an organization structure into the technology, and making the technology work the way the enterprise works, not trying to shoehorn technology or shoehorn an enterprise process into what technology can handle. So there's a lot of interesting stuff going on there. And then also one of the things that we cover in the book in detail is OPA and Gatekeeper and building bespoke policies in Rego. And we also cover a lot of pod security policies, except pod security policies are going to be gone by 1.22, I think is when pod security policies go away. They've been deprecated. And so kind of covering how you would replace pod security policies, because there's a hodgepodge of tools out there right now, but I haven't really found one that is a drop-in replacement. So there's a lot of stuff around that I would want to do as well. It's a huge topic. This book is 650 pages, I think.
Deep,
and we're just scratching it.
Yeah. So we do have a couple of questions. One, Hilkan is asking, he keeps hearing that Tekton is still in preview, and if you know if there's an ETA for the GA release. And Diane Fedema is asking, why do we need Argo CD in addition to Tekton? What does Argo do for us that Tekton cannot?
Oh, wow, those are great questions. So the first one, I'll actually defer to Red Hat on that one. So there's Tekton, which is its own project. It's part of the Knative kind of ecosystem. And then there's Red Hat's Tekton operator pipelines, where Red Hat is migrating off of Jenkins as its official build technology. So I don't work for Red Hat, so I'll defer to someone from Red Hat to be able to answer that one. The second question, why do we need Argo if we have Tekton? That is a great question, because they do two different things. Tekton is a build technology. Its primary goal in life is to take source code and create artifacts. It's the integration side of CI/CD. A lot of times the waters get really muddied between CI and CD. But honestly, at the end of the day, Tekton is not designed to be a deployment tool. Could you deploy directly using it? You could. And I am absolutely 100% guilty of writing CI pipelines that deploy code. But that's not really what it's designed to do. When you think about it from a higher level, the reason why GitOps becomes so powerful and using something like Argo in conjunction with CD or CI in Tekton is that it allows you to map your enterprise's processes into technology a lot more easily. So imagine we're not talking about Kubernetes, we're talking about just software in general. And you work in a large enterprise, and you have to go through a change board before you can push things into production. So we've all gone through this, right? Where we have to write up a ticket, we put it in the change board, it's got to go before the change board, somebody has to approve it, and then then you run your deployment plan. Well, you could do that with a pipeline, but is the pipeline going to sit there? You're going to create a pipeline object. How are you going to audit that? Like, once you're done with your change control process, what's the artifact that you put into your ticket that proves that what you've done is completed? Now you use the GitOps model where everything's in Git. Git is now your source of record. So you just put the link to the commit into your change control ticket as the proof that everything's done, and you can now backtrack through Git the merge from dev, the push to dev, that links via commit back to the application commit merge request. So with all you can squash everything, so all it's in there. You now have a record all the way back. So you could do it directly with Tekton, but it's square peg round hole. It's not really what it's designed to do. You could smash a nail in with the butt end of a screwdriver. It's not really the best way to do it, though.
Yeah, and we do want to keep our compliance and risks and audit people happy. So being able to document that is really, I think, key. I think some of us who work inside of the vendor houses and we're doing build stuffs and creating POCs, we kind of sometimes cheat. and actually not sometimes, mostly cheat and build stuff. And then we forget about the realities of working in big banks and enterprises with heavy lifting around compliance and audit practices. So yeah, it really does save people's butts, basically, to have Argo in the mix. So that's always, I think, one of the things that I love, Marc, about that you always bring us back to here is what the reality is for the enterprises that are trying to deploy all of this. And it's kind of interesting. So what kind of have you seen? Your co-author is at this big old bank. What kind of adoption have you seen of this? The movement away from Jenkins to Tekton CD? Is it like this tsunami? Is it just a natural evolution?
It's gradual, I think. I think a lot of times in the talking circuit, we tend to gravitate to the new shiny.
Mm-hmm.
It's not because Jenkins is bad or there's something wrong with Jenkins. I've known plenty of shops are like, nah, we're happy with Jenkins. We're just going to keep using it. Mazel tov, right? You don't have to go chase the new shiny if you don't need to. Where Tekton becomes really powerful is, one, it gives you the ability to leverage Kubernetes built-in multi-tenant capabilities, which is something that Jenkins is not that great at. Multi-tenant Jenkins is really, really hard to do correctly. And so you're piggybacking off of everything Kubernetes gives you between RBAC and pod security policies and secret management and namespaces, and being able to construct an environment where only certain people get access to that. It also makes it really easy to be able to set up a development workspace. So, I'm not going to be developing these tasks in that build namespace, right? That would be bad. I want to do it inside of my own personal namespace. So by having that flexibility where I now don't have to run a Jenkins, well, that now gives me the ability to just create these objects locally and then allow it to go ahead and start going. So it gives you a combined security model of Kubernetes. It gives you a lot more flexibility. But that said, it also adds a lot of complexity. And it's really important that if you don't have an effective automation strategy, if you do this in a bespoke way, you're leaving yourself open to a lot of pain.
Yeah, I love that hipster word, bespoke. It's like, it's wonderful if
it's a fun word.
If you're making a craft beer, it's great. If you're doing, I don't know, tailoring clothes or something like that. But if you're doing enterprise deployments and pipelines, bespoke is probably not the way. And the last question we have here is, would you advise integrating Argo CD with a Jenkins PL? I'm not quite sure what PL stands for, but pipeline, I guess.
Pipeline, yeah. I don't see why not. They're two different technologies, right? Argo is making sure that your manifests in Git are your objects in Kubernetes. Jenkins is a CI tool. So, yes, you can, just like with Tekton, you can use it for CD, but it's not advisable. It's great for generating artifacts. That's what Tekton does, or that's what Jenkins does. So you want to rip out Jenkins and use it or you want to rip out Tekton from this presentation and use Jenkins. Perfectly valid approach. It's really up to what y'all are best at. Jenkins is not going anywhere anytime soon.
Yeah.
So it is still a great technology.
No, it's just, we have a cornucopia of tools that we can choose from, and if you've baked into Jenkins for years, that's going to be, pulling that out and rerouting is not really what we're advising here. It's just listening.
Absolutely not. Yep.
Listening for what the bright, shiny new objects are, explaining how it all works, and hopefully getting some of you to give us your feedback. Take a look and read this book. Definitely take advantage of it and give Marc some feedback. And I'm I'm betting that that final chapter isn't as lightweight as you think it is, and but I'll look forward to um, another episode of this, and I'm totally grateful for you taking the time today to share this. A lot of interest in this topic. I'm sure we'll have you back, and we look forward to seeing you. Did you get a talk or any? Are you participating in KubeCon coming up in November?
Yeah, so I'm going to be doing a lightning talk at the Security Day, I think it's called, or the security conference the day before. A lightning talk on why you should be using OpenID Connect and not certificates when authenticating to your cluster. So that was a lot of fun to put together.
Oh, cool. Yeah, I love lightning talks. First of all, because you don't have to take forever, and you're off the stage as quickly as possible, and it's great. But it really is. It makes people be very succinct, so it's wonderful. And as well, we'll be doing a lot of talks. I don't think we have a Tekton talk, but we have a lot of great talks coming at the OpenShift Commons Gathering. That's also on day 0. So please do join us there. We front loaded that with a lot of OpenShift 4.6 release. We've got Clayton and Derek Carr and Michael Barrett reprising their Two Ferns conversation from the San Diego North American KubeCon when we were on the boat. So we've gone from being in person to being on a boat to being virtual. I can't imagine what 2021 is going to bring.
The moon.
If it's not virtual, man, who knows? Hopefully, maybe we'll all be on a cruise. No, we won't be on a cruise ship.
No cruise. No cruise ships.
No cruise ships. So with that, I'm going to thank you and wish everybody well. Be safe, be healthy, and we'll talk to you all. Tomorrow is the LATAM, the OpenShift Commons in Vivo. We'll talk to you tomorrow in Spanish at 2 p.m. Pacific time. I think we're talking about MTA. What is that? Migration tools applications. I don't even know, and I'm going to be listening to it in Spanish, so it's going to be really great. So anyways, take care, everybody, and we'll talk to you all soon.
Thanks, Diane.
Recording has stopped.
That was awesome. Thanks.
That was fun. And it worked.
And it all worked. There was like, yeah, I'm like, oh my, you had so many screens open. I was like, oh.